Alright, 12.6, surface area of cones. Students will be able to find lateral and surface area of cones. Let's define a couple terms here real quick. First thing they want us to talk about is what an axis is. An axis is the segment from the center of the base to the vertex. So, center of the base to the vertex. So yeah, you see here the axis is kind of tilted because it's an oblique cone, and here it goes straight up and down because it's a right cone. So if it doesn't go straight up and down, it's called oblique. If it's kind of tilted like this, it's an oblique cone. But our formulas are going to be, they're actually going to be the same, which is kind of nice. So the segment from the vertex to the base, that is the altitude. The segment from the vertex to the base where the segment is perpendicular to the base. Alright, so that's the altitude. So that's this guy. See, the altitude is always going to be perpendicular to the base. It can't, where the axis can be tilted, the altitude is not tilted. So here the altitude is the same place as the axis. And so we would say a cone with an altitude that is also an axis is a right cone. Otherwise, it is called an oblique cone. Not a left cone. Get it? Anyway. A lateral area of a cone. Alright, so we need to know the formula for this. And if you want an explanation for the formula, it's in the textbook, and I put it up on the board the other day, but it's just a pretty simple formula. It's just that the lateral area equals pi times the radius times the slant height. So, pretty simple. So this next problem, they say Diego has a conical shade with an altitude of 6 inches and a diameter of 12 inches. Find the lateral area of the lampshade. Well, that's great that they give me the altitude and the diameter, but I need the radius and the slant height. So we have to figure out a way to find the radius and slant height. Well, let's take a look at what we know. So they give me this figure, and they're telling me, hey, this distance is really 6. That's what this little arrows up and down means. It means its height is 6. And if the diameter is 12, that means that the radius here is 6. So we got 6 and 6, and that has to be a right angle. Well, we learned something a while back about right isosceles triangles, or 45, 45, 90 triangles, and that is that we have a shortcut for finding the hypotenuse. Now, again, we could just use Pythagorean theorem, 6 squared plus 6 squared equals the hypotenuse squared, but the shortcut is just we take the side and we multiply it by rad 2, and that's it. So now we know the slant height and we know the radius, so we're ready to plug things in. So we're going to say lateral area equals pi, or my radius is 6, and my slant height is 6 rad 2. So lateral area equals 36 pi rad 2, and we would say inches squared. And that's actually an exact answer, because without a calculator we can't get any more exact. But if we have a calculator we can, so we can plug in L equals, and we can plug all of that in the calculator, and we can get back about 159.9. Alright, that's also inches squared. So both of those are legitimate answers, just depends on what they ask for. Alright, let's go on to the next page. Alright, the last problem here is just on the surface area of a cone. Well, if the lateral area is pi RL, well, the only thing that we have left is the circle here. So we just have to add the area of the base. So we could say, again, the lateral area plus the base. Or if we want to write it out exactly, it would be the surface area equals pi RL plus pi R squared. So we have the lateral area plus the base area. And now this one's pretty straightforward. They give us the slant height and they give us the radius. So we're just plugging these values right in. You should be able to do this on your own, so if you want, go ahead and pause it. Otherwise, yeah, watch me fill in the information. all you're doing is plugging the values in. So here's pi times my radius times my slant height plus pi r squared, because that's the area of a circle. And then I could plug all that into my calculator, or I could do this kind of like one step at a time. So I could do 13.6 times 4.7, and I would get that that's 63.92 pi. And I could say, well, 4.7 squared is 22.09, and then we'd have a pi. Then I could do 22.09 plus 63.92, and I would get 86.01 pi. And then finally I could just take that and multiply it by pi, and I would get 270 about, we'll just say like 208. Okay, and that would be centimeters squared. And again, either one of these answers is actually fine, because this top one is an exact answer without a calculator, and this is with a calculator. So there we go. There's 12.6. Not too shabby. Shouldn't be that hard. The tricky part is just making sure you know the formulas. Alright, see you guys in the next video.